afternoon, good evening. Welcome to my presentation. I am student Marang Mosiane, and this is my student number. Now, let's just get into the presentation quickly. Now, we were given coordinates for our construction site. All right, as you can see on these coordinates from Google Earth, this is for the dam. This one is a coordinates for the reinforcement. Now, the reason why this construction is very important is because this is to improve supply of water to surrounding rural communities. The proposed development aims to provide reliable water storage, flood control, and a sustainable water supply for domestic use and irrigation. Now, if we move on, you find that we had to find also a climate region in order to check rainfall or what kind of an area it is, whether it's wet, moderate, or dry. We found out that the area is situated there. That area is less than 2 in terms of the vernal N value. Therefore, it is a wet area. And now when you look into map, the topographic map, that this concept topographic map, it shows that the area is moderately smooth, with moderately steep terrain with distinct ridges and valleys. Now, in accordance to the rock types or the rock types that we found on from the Council of Ge Geoscience, these are the different rock types that we have. All right, in that particular area, our dam is on this area, our reservoir is there. Now, as you can see, in accordance to the code, the RHLA, that's the type of a rock type that we find where the dam is supposed to be situated together with the granite, and then the reservoir as well, which is situated there. That's for our QA or our alluvium a rock unit, which falls under the rock category sedimentary. And then our MG falls as our granite falls under igneous rocks, and then our RHL A falls under sedimentary rock, where we have our quartzite and or including our where we have our fine-grained quartzite and our feldspatic quartzite. Now, according to our land types of the type of soils that we will be finding in accordance to what is needed in the lab for us to test, we found that mostly is the majority is clay soil in accordance to this table. Now this map is derived from Steelport, which is at least southern eastern side of where our construction site is. Now here, from the assumption of the manual that I received from our geo module, this manual, I have found out the descriptor of our alluvial rock units, whereby it shows that our assumption of gravel, sand, silt, and clays soil types is what we can be expecting from our site. Now, these are the different conditions and these are the recommendations. Now, for all of these conditions, as you can see here, is that it's excavating, recompacting, and then also engineering controlled fill. So we're filling back in so that everything can be as solid as possible. These are the different laboratory tests, the DCP, the borehole yield testing, the soil sampling, the sieve analysis, and also our uniaxial compression strength. All right, and then in conclusion of this matter, the site may be suitable for the proposed dam and reservoir development, but its suitability cannot be confirmed without any further site-specific geotechnical investigations. The result of the proposed field and laboratory testing should be used to establish the final foundation design, identify and required soil replacement and stabilization, assess seepage and groundwater conditions, and confirm the overall stability and long-term performance of the proposed water storage infrastructure. The findings from the detailed investigation should ultimately guide the final engineering design and construction methodology for the project. Thank you very much for listening to my presentation. I would have wanted to explain more, but then time is not on my side. Thank you. Bye.